Right now, while you're watching this, a 15-year-old piece of invisible security infrastructure sitting underneath hundreds of millions of Windows and Linux computers around the world is quietly expiring, and almost none of the people who own those machines have any idea it's happening. Because this isn't a virus, it isn't a hack, it isn't a headline-grabbing breach, it's something far stranger. A trust system with a built-in countdown timer that was set 15 years ago and is now finally running out. And the countdown has a name, Secure Boot Certificates, issued by Microsoft back in 2011, designed from day one with an expiration date baked in, and that expiration date has arrived. June 24th, 2026 is when the first major certificate expires, with the final one following in October. And before you assume this means your computer is about to stop turning on, it doesn't. What's actually happening is quieter than that, and in some ways more dangerous, because without these certificates being replaced, your system gradually loses the ability to verify that the software running before your operating system even loads is legitimate. And the Door Secure Boot was built to keep locked against the most serious category of malware that exists, the kind that installs itself below Windows entirely, invisible to every antivirus tool you've ever trusted, starts to swing open. And if you're running Linux alongside Windows in a dual boot setup, the stakes are even more immediate, and the fix requires a very specific order of operations that most tutorials online are already getting wrong. So let's walk through exactly what's expiring, exactly what happens if you do nothing, and exactly what you need to do right now for both Windows and Linux to stay protected. And to understand why any of this matters, you first need to understand what Secure Boot actually does in the handful of seconds before your operating system ever appears on screen. Because every modern PC has firmware built directly into the motherboard called UEFI, the software that runs the instant you press the power button before Windows or Linux has any chance to start. And UEFI's job is to initialize the hardware and hand control over to a bootloader, which then loads your operating system. And Secure Boot is the feature inside UEFI that adds a verification checkpoint to that handoff before control passes to any bootloader. Secure Boot checks whether that bootloader carries a valid digital signature from a trusted authority. If the signature checks out, the boot process continues normally. If it doesn't, the system refuses to proceed, and the unauthorized code never runs at all. And that single checkpoint is what makes Secure Boot so valuable, because even if an attacker manages to plant a malicious bootloader on your drive, your system detects the untrusted signature and blocks it before it ever gets the chance to execute. And the entire protection model rests on the certificates that define which signatures count as trusted, and those are precisely the certificates expiring right now, and there are 3 of them, each responsible for a different link in the chain. The first is the Microsoft Corporation KEK-CA 2011, expiring June 24th, 2026, the Key Exchange Key Certificate that authorizes updates to the secure boot trust databases, and without a valid KEK, your system loses the ability to receive new trusted signatures or new revocations, meaning it can no longer be taught to trust new bootloaders or told to distrust ones that have been compromised. The second is the Microsoft UEFI CA 2011, expiring June 27th, 2026, the certificate that has historically signed third-party bootloaders and EFI applications, which is exactly why it matters to every Linux distribution using Secure Boot. Ubuntu, Fedora, Red Hat Enterprise, Linux, Debian, and virtually every other major distribution rely on a small bootloader component called shim, which is signed by this very certificate, and once it expires, any shim signed only under the 2011 authority becomes a liability inside the trust chain going forward. And the third is the Microsoft Windows Production PCA 2011, expiring October 19th, 2026, the certificate that signs the Windows bootloader components themselves, making it the most directly relevant certificate for pure Windows users. And the fact that 3 separate certificates are expiring across 3 different dates spread over 4 months means this isn't a single cliff edge, it's a rolling deadline. And here's the distinction Microsoft has been trying to communicate clearly, one that most alarming headlines have gotten completely wrong. Your computer is not going to stop booting the day after June 24th, because the UEFI specification allows systems to boot from software signed by a certificate that has since expired, as long as that signature was valid at the moment it was applied, a principle called the time of signing rule, and it's exactly what keeps your existing Windows installation from suddenly refusing to start once the certificates expire, because the bootloader already sitting on your drive was signed back when the 2011 certificates were still valid, and that historical validity is preserved. So the nightmare scenario, millions of computers turning into bricks overnight, simply isn't what's coming. What's coming instead is a slow, quiet erosion of security that is in many ways more dangerous precisely because it never produces the kind of obvious crisis that forces anyone to act. And here's what that slow burn actually looks like in practice. Once the certificates expire, any system that hasn't received the replacement 2023 certificates loses the ability to verify new bootloader signatures going forward. It can no longer trust new versions of the Windows bootloader signed under the 2023 chain, and it can no longer receive meaningful updates to the secure boot DBX, the block list that tells your system which compromised bootloaders to reject outright. And that DBX gap is the detail security researchers are most concerned about right now, because there is an active, documented family of bootkit malware known as Black Lotus and its successors, malware built specifically to target the pre-boot environment, install itself below the operating system, and survive reboots, full reinstalls, and antivirus scans without a trace. The DBX block list is the exact mechanism that lets Microsoft tell your system to reject known malicious bootloaders the moment new variants are discovered. And if your DBX can no longer be updated because your KEKK has expired, your system permanently loses that defensive capability. And according to security researchers, attempting to set up a new Linux dual boot installation on an unupdated machine could become outright impossible because the signed shim simply won't be trusted by an aging certificate chain. The window between where most people's computers sit right now and where they need to be is closing. And it's closing quietly, without a warning banner, without a pop-up demanding immediate attention. And there's a second, entirely separate landmine buried inside the story that anyone running Windows with drive encryption absolutely needs to understand before touching a single setting. Because BitLocker, Microsoft's full drive encryption system, ties its default unlocking behavior to something called PCR7, a measurement of your system's secure boot configuration taken by the TPM chip every single time you boot. And BitLocker uses that measurement to decide whether to unlock your drive automatically or demand a recovery key. And when secure boot certificates change, that TPM measurement changes with them. And when the measurement changes, BitLocker sees a configuration it no longer recognizes and immediately demands your 48-character recovery key before it will unlock anything. This is not a bug. It is BitLocker doing precisely what it was engineered to do, but it means that anyone who applies secure boot certificate updates or firmware updates touching secure boot configuration without first locating their BitLocker. Recovery key is walking directly into the possibility of being locked out of their own encrypted drive. And Microsoft has warned about this explicitly, telling administrators to find that recovery key before doing anything else. It lives inside your Microsoft account for home users, or inside Active Directory or Azure AD for enterprise devices. And skipping that single step is exactly what turns a routine security update into a frantic call to tech support wondering why your own computer suddenly refuses to let you in. And for Windows users on supported versions, including Windows 10, Windows 11, and Windows Server going back to 2012, the primary update path runs straight through Windows Update. Microsoft began rolling out the replacement 2023 certificates, starting with the March 2026 cumulative update. So if your updates are current and not paused, and Secure Boot is enabled, there is a real chance you already have the new certificates in place. And you can verify this yourself by opening PowerShell as an administrator and checking the relevant UEFI certificate database entries directly. Though the more important nuance here is that a Windows update and a firmware update are not the same thing. And confusing the two is the single most common way people end up believing they're protected when they're not, because the certificate databases themselves live inside your device's firmware, not inside Windows, which means you may also need a separate firmware update from your motherboard or PC manufacturer. And that firmware side of the story is significantly messier than the Windows side, because the update process is genuinely split across two systems that don't always move together. Windows Update handles the operating system's awareness of the new 2023 trust chain, but the actual low-level firmware databases where certificate entries physically live are controlled entirely by whoever built your motherboard or laptop. Microsoft cannot push a firmware update to a Dell laptop. Dell has to build that update, test it, and distribute it through its own channel. And for a huge number of consumer devices, that means manually visiting the manufacturer's support site and downloading a BIOS update yourself, because OEM firmware delivery through Windows Update is only reliably available on newer devices with modern standby support, which creates a strange, uncomfortable gap. Microsoft can tell 500 million Windows devices that new certificates exist, but whether those certificates actually reach the firmware on any specific machine depends on decisions made independently by dozens of different hardware manufacturers, some of whom have already stopped producing updates for older models entirely. And this fragmentation has quietly been the defining challenge of PC security at the firmware level for the entire history of the UEFI standard. But the 2026 deadline is finally dragging it into the open where it can't be ignored anymore. And if you're running Linux, either standalone or in a dual boot setup, The situation is more nuanced and requires understanding exactly how Linux boots on secure boot hardware to avoid accidentally making things worse, because when secure boot is enabled on a Linux system, the boot process passes through an intermediary layer called shim, a small bootloader component signed by Microsoft using the UEFI CA certificate, giving it initial trust authority on secure boot-enabled hardware. Shim then performs its own verification on the next stage of the process. Typically Grub or another bootloader signed with the distribution's own keys, and the entire chain only works because Microsoft trusts Shim. Shim trusts the distribution's bootloader, and the distribution's bootloader trusts the kernel, a chain that depends entirely on Microsoft's UEFI CA certificate remaining valid. And once that certificate expires on June 27, 2026, any new shim binaries signed only under the 2011 authority will stop properly extending trust on systems that have already moved to the 2023 chain. Red Hat addressed this for RHEL back in May 2026, shipping a new shim signed with both the 2011 and 2023 certificates simultaneously. But if your system hasn't received updates in a long time, or if you installed your distribution years ago and never touched the shim package specifically, you could be sitting on outdated trust infrastructure right now without knowing it. And for anyone running Windows and Linux together, the sequence in which you apply updates genuinely matters. Get the order wrong, and you risk being unable to boot into Linux after a Windows update completes. And the correct sequence looks like this: update Linux first, apply every available system update. On Ubuntu, that means running your standard update and upgrade commands. On Fedora or RHEL, that means running the DNF update process. And confirm specifically that your shim package has been updated to a version signed with the 2023 certificate. Only after that step is complete should you return to Windows and apply all pending updates, including any firmware update available, through Windows Update or your manufacturer's site. And immediately after any firmware update, expect a BitLocker recovery key prompt. So have that key ready before you reboot. Once the Windows side is finished, boot back into Linux from your boot menu to confirm it still works. If it does, both trust chains are properly aligned. And if Linux fails to boot after the Windows certificate update, it almost always means the Linux shim wasn't updated first, a situation that is fully recoverable by booting into a live Linux environment and updating shim manually, but one that is far more stressful to fix after the fact than to simply avoid by following the right order from the start. And there is one category of device completely exempt from all of this worth naming clearly, so you don't waste time chasing updates that don't apply to your hardware. Copilot Plus PCs released in 2025, including newer Surface devices from that period, shipped with updated UEFI firmware and newer certificate chains already built in, meaning the 2011 certificates were never the root of their trust to begin with. If that describes your machine, there's nothing specific you need to do here. And for everyone else, the determining factor is simple. If your device is running a version of Windows or a Linux distribution that shipped since 2012 and secure boot is enabled, this transition applies to you, and knowing which category your device actually falls into is the first real step toward applying the right fix to the right machine instead of guessing. And there's an enterprise dimension to this story that security teams genuinely cannot afford to ignore. Because organizations in regulated industries, healthcare, finance, government, and defense contracting, operate under security baselines that require secure boot to be enabled and functioning correctly on every managed endpoint. And once the 2011 certificates expire and devices slip into what Microsoft describes as a degraded security state, compliance tools, including Microsoft Intune, will begin flagging those devices as non-compliant. And for organizations subject to frameworks like NIST, unresolved certificate chains, stop being a technical footnote and start becoming a documented, auditable vulnerability. Security teams that complete this transition before June 24th will have nothing to explain to anyone. Security teams that don't will spend the back half of 2026 answering to auditors and executives about why known, documented, advanced warned vulnerabilities were left sitting open on their endpoints. And the honest, uncomfortable lesson buried inside this entire story is one the technology industry needs to get dramatically better at communicating. Because security infrastructure has expiration dates by design, and the 2011 secure boot certificates were always meant to be temporary, given a 15-year lifespan specifically. So cryptographic trust never depends forever on aging algorithms and keys that modern computing could eventually outpace. And the real mistake here was never setting an expiration date. The mistake was assuming that hundreds of millions of devices would transition smoothly, automatically, and invisibly without requiring any understanding or action from the ordinary people whose machines are actually affected. And most home users have never heard the phrase UEFI certificate in their life. have no mental model of what secure boot even does, and have absolutely no idea that a 15-year-old trust infrastructure running beneath their operating system is quietly expiring while they check email and stream video without a second thought, and closing that gap, the distance between what's technically happening at the firmware level and what ordinary people actually understand, is exactly why this story matters. So here's what you actually need to do. Starting today, if you're a Windows-only user, confirm your updates aren't paused, run everything currently available, check your PC manufacturer's website for a firmware update mentioning a 2023 secure boot certificate support. Locate your BitLocker recovery key before touching any firmware update, and verify the new UEFI CA certificate is present, using PowerShell once you're done if you're running Linux in a dual boot configuration. Update Linux first, confirm shim has moved to the 2023 signature, then apply Windows and firmware updates, then test that Linux still boots before you consider the job finished. If you're on a Copilot Plus PC from 2025 or later, you're already covered and can spend your energy elsewhere. And if you manage a fleet of business machines, treat every single device as its own item to verify, because automatic delivery is never guaranteed across older hardware. And the machines most likely to get missed in a mass rollout are exactly the machines most likely to become the weakest point in your entire security posture once June 24th, 2026 has come and gone. And that is ultimately the real story hiding underneath a 15-year-old certificate, quietly reaching its expiration date. Not a single dramatic event, but a slow, invisible test of whether an entire industry can get hundreds of millions of ordinary people to take one small, boring, technical action before a countdown clock nobody was watching finally hit zero.